Hello everyone and welcome back to this TFK Deep Learning tutorial series. This is the episode 1.2 of getting started with TensorFlow and Tensorboard. So let's see what we are going to learn in this episode. We'll look into what is TensorFlow, why TensorFlow, basic structure of TensorFlow. We'll basically look into what session and graph is, and then we'll look into installing of TensorFlow. I think I've done a video on that already, so I'll see if I do it again, or let's see. And then we'll obviously get started with TensorFlow basic implementation, basic program implementation in a Python notebook, and then we'll also see how we can use TensorBoard. And in this episode, we'll just use a graph visualizer to visualize the network, the graph of the network. And then we'll end this with by looking into constant variables and placeholders. Okay, so but before we get into it, let's recap of the previous episode. So in the previous episode, we discussed that broadly we can categorize artificial intelligence as any entity which can mimic, human-like behavior such as visual perception, speech recognition, decision making, taking actions, natural language processing, learning, reasoning, and memory. So broadly considering this, we can say this that AI comprises of all these attributes. And then we also discuss how any learning algorithm is represented. So given any raw input, instead of taking the raw input, we get its feature. So in case of bike, we can have wheels and handlebars, and those features are then fed into learning algorithm to learn it. And those learning algorithm for classification purpose will be a decision boundary, deciding between bikes and non-bikes. Okay. And then we discussed that how deep learning is different from machine learning. So in traditional machine learning, we have a hand engineered feature extraction, and after feature we then feed it to classifier. But in deep learning it is combined, and what we get, what we call it as end-to-end learning. We give an input and we get an output. And then we also discuss a structure of a single artificial neuron. So it will have inputs, and those inputs will be weighted, and then we'll have a product of sum. We add a bias to it, to which activation function is applied. So this is the basic structural unit of any artificial neural network. And using this single artificial neuron, we can construct any complex, new artificial neural network like deep neural network or convolution neural network or recurrent neural network. Then we broadly discussed about different types of learning like supervised, semi-supervised, reinforcement, unsupervised, and we touched the topic of regression and classification. And then we discussed how any training algorithm is executed. We take the input training data, we feed it, forward propagate it, then we compute the error, we back propagate the error, and we correct the weights, and this how the model learns its parameter, and hence the model is trained. So that's all, and let's move to episode 1.2. So in episode 1.2, we are going to discuss about TensorFlow. So it's an open source software library developed by Google, and it was released in November 2015. And we can basically design, build, and train any deep learning model using this TensorFlow library. So before we go into the uh, advantage of TensorFlow, you can go to this wiki page, and you can actually can show you here, and you can see the different deep learning libraries and a comparison between them. So there's softwares, the creators, whether it's open source or not, what it's written in, its interface, CUDA support, recurrent net support, convolution net support. So there are Cafe 2, deep learning for Java, Keras, MatConvNet, MXNet, PyTorch, TensorFlow, Theano, everything. So you can just go and have a look at it. And so this is an old post, and it shows how TensorFlow is growing among the researchers, practitioners, and even in industry. And this is a post 2 months ago, and sorry,
you can see here very clearly that the demand of TensorFlow is very high compared to other libraries. Great. And also in case of tutorial search, the request for TensorFlow tutorial search is really increasing, as you can see, from May 15, September 18. So this is the blue line. It's going very high compared to other libraries. Okay, so TensorFlow, it's an open source and it has C++ backends, because of which it's faster. It provides both C++ and Python API. It also provides Keras API, tf.keras, and which will be one of my topic which I'll try to explore, the tf.keras API. Python API of TensorFlow is complete and easy to use. We can deploy it in one or more CPUs or GPUs in a desktop server or Android iOS devices. And it has number of cool features like TensorBoard. We'll look into it in this episode. Checkpoints, and in TensorFlow application, everything is within a structure called data flow graph. We'll look into what it is, and basically, TensorFlow, we can build anything from scratch. Okay, so I was looking for TensorFlow tutorial and I found this course really very complete from beginning. They explain everything, and I'll provide the link of this, and you can download the notes and the slides and you can read it. And many of the points which I'll explain in this episode are taken from those slides and notes, because they're really cool, and I just want to cover introduction of TensorFlow, so I got from them. Okay, but you can go and have a look at the site. And there are a number of simplified TensorFlow libraries like tflearn, tfslim, and we have higher level API like Keras, tflearn, PrettyTensor. We'll explore Keras. So now let's understand TensorFlow. So it's an open source software library for numerical computation using data flow graphs. So what is data flow graph? So this is a data flow graph, or network defined in TensorFlow. So it's a graph in which the data is flowing. So the graph consists of two things. One is nodes and other is edges. So nodes here are the mathematical operations that need to be executed, and the edges here represents the flow of data. So the data is actually the multi-dimensional arrays called as tensors. So we'll look into what is graph and what is session and variable and placeholder in the next slide. Okay, excuse me. So for any TensorFlow structure, there are two steps. Step one is building a data flow graph. So TensorFlow will first define a graph, that is all the mathematical operations and the data that will be flowing between them, but it will not be executing them. For executing those graph, we need to launch those graph into session, which will execute all those operations as computations. Okay, so it can be better defined with this definition, which I got from this blog. And so it says a graph defines the computation. So it will just define the computation. It does not compute anything. It does not hold any values. It just defines the operations that you will specify in your code. And then once the graph has been uh, you know what to say defined, then a session allows to execute the graph or the part of graph. So based on what need to be executed, it will allocate resources like memory or computation for that a specific subgraph or graph, and then it will also hold the values of intermediate result and the variables. Okay, so building graph is like defining the computation, and executing or running the session is like executing the defined computations. So
So you can go and have a look at this blog. I'll give a link to it, and you can see there's an example also, and we'll see while we go to Jupyter Notebook to implement what this two exactly mean. Okay, so in TensorFlow everything is defined in a term of something called data flow graph. So what exactly is data flow? So it's defined here. It's a common programming model for parallel computing, and in data flow graph The nodes represents the units of computation, and the edges represents the data consumed or produced by the computation. So basically, as I've discussed earlier also, the nodes are, all the operation, and edges are the tensors or data flowing between them. So all the data's bit flowing with different operations are called tensors, and you see this tensor flowing between the different operations, and hence the name TensorFlow. So each operation will take in tensor as an input, and it will output a tensor too. So let's see what exactly this tensor you mean. Okay, so tensor is any data. So for example, tensor is an n-dimensional array, and a zero-dimensional tensor will be a normal scalar number like 5, or if you visualize it, it's a point. And a 1D tensor will be a vector of number like this, and it will be a line. And a 2D tensor will be a matrix like this, or say you can say it's as an image. And 3D tensor will be a cube, or if you say in case of video, the different frames when stacked in the third depth dimension, we get this 3D tensor as cube. So the length, breadth, and the height. Okay, so this is what it is: 1D tensor, 2D tensor is a matrix, 3D tensor is a cube, and then again 4D tensor will be a vector of cube, 5D tensor will be a matrix of cube, and 6D tensor will be a cube of cube. So it can be like, for example, when you're training a neural network, suppose a CNN, and you have 100 images, so the dimension will be, so let me write it in the next or here. So the dimension will be 100 comma, number of rows say 32, number of columns say 32 again, sorry for the writing, and number of channels say 3. So this is what the shape of input data will be when we are feeding 100 RGB images. So it will be a 4D tensor, something like that. So when we implement, you'll see all these shapes, and yeah, so basically I just want to give you an idea. So I've discussed, I'm telling it again and again. So it is two-step. One is building graph, that's defining the graph, something like this. So you define all the nodes and the operations. The nodes can be any operators, it can be any variables or constant, and the edges will be the tensors like this: data 4, 8. And then running this session means executing this defined computation in a session. So when we execute it, this 8 will flow here, 4 will flow here, this add operation will be computed, and we'll get the result 12. So here we defined the the variables, we define the operations, and here we execute them, so in the session. Okay, so in TensorFlow, the constant variable operations are collectively known as ops. So you will get that in your vocabulary. And yeah, so now coming to installing TensorFlow. So let's discuss the installation of TensorFlow. So it's actually I have done a video on the installation of TensorFlow, and the link will be appearing somewhere on the screen. And but it's pretty simple. So actually TensorFlow for Windows is available after Python 3.5. So you should have Python 3.5, and using Anaconda, it's really very easy. So you just need to create a virtual environment with Python 3.5, and then install the TensorFlow CPU version. So let me install and show you here. So I actually created a if you go here, where is it? Yeah, so if you go to installing TensorFlow on Windows, I think using Anaconda is really very easy. So you just create a Python virtual environment, you activate it, and then you simply, I have activated this Python 3.5 CPU one. So I'm installing the CPU one, and I'll simply, do pip install TensorFlow, and this should install TensorFlow for me. So it will be TensorFlow, the latest version 1.4.0, and it is for Python 3.5. So it's installing the collected packages. So there were packages already there because I just uninstalled to show you. So this is one way you can install. Another is using conda forge. So this is the command. So either for Linux, Windows, conda install -c conda for TensorFlow, and it will install the latest version of the TensorFlow in your system. So it's saying successfully installed TensorFlow 1.4.0. So you create a virtual environment if you are using Anaconda 2, and yeah, even in Anaconda 3, if you want Python 3.5, then you have to again create virtual environment in Anaconda 3 also. But if you want just 3.6, then no need to. So this way you just install the TensorFlow, and uh, yeah, so the environment I am having, actually I am having both Python 3.6, and in that the latest version was 1.3.0, and now just I install this and I got TensorFlow 1.4.0 with Python 3.5. But I say we use Python 3.5 because when we are using Tensorboard, in there we get more better visualization of the graph. Okay, the first program in TensorFlow. So what we'll do, we'll import the TensorFlow, we'll define two constant variables, and then we'll define one operation, and then we'll initiate one session, and then run the defined graph. So this is our defined graph, and we'll run this defined graph into this session, and we'll see the result, and then we'll close the session to release the resources. So this is what any basic TensorFlow program will be: defining the graph, uh, running it into a session, and then closing the session. And let's see by running it in a Jupyter notebook. So let me go to my Jupyter notebook here. Yeah, so first we'll import TensorFlow as TF, and building the graph, as I told you, the first step. So we'll define uh, the two constant, so a constant 2 and a constant 10, and then let's define one operation or a computation, that's tf.add, simple add operation. Okay, now you see, now if when you try to run the let's print it out what C value it is. And so you see it's saying that it doesn't has any value. It says that it's a tensor having operation of add. Its shape will be of scalar, the result shape, data type will be integer, but it is not giving its value. Why? Because now the graph has just been built, the operations haven't been executed yet. So that's what I mean by defining the graph and executing the graph or the computation. On printing the value of C, you will not get 12. Okay, so now in order to get it, we have to initialize the session and run a computation, or run our computation in that graph. So we can define the session with session equal to tf.session. Then we'll run it by session dot run C. C is the operation, and then we'll see the result. And then when we have executed it, we'll close the session. So on running this, we should get 12. Okay, and to avoid like closing the session every time, so here we are manually closing it after running the computation, we can use a with block. So with tf.session as ses, we can just result ses.run, print the result is result, and we will not close it. Once the things are executed, it will automatically close. Okay, so again the basic structure remains the same. We build the graph and we define the operations. So basically all the operations are the building of the graph, and then we run the graph or subgraph by starting in a session. Okay, so let's get back. And so this was our first program. So what is the advantage of running the graph through a session? So this also are the few slides taken from Stanford class, and you can go and have a look at it. It's really good and explain it self-explanatory, but I'm just giving you overview since I'm making a series. Okay, so advantage of running the subgraph through a session is that when we are running it, we will run only that specific part, will not execute the whole graph. So let's see with this example. So x is equal to 2, y is equal to 3. We define an add operation between this. We define a multiply operation between x and y again, and we define some useless operation which will take x and the add operation. Okay, and there is one power operation between add and multiple operations. So when you start the session and execute it, so when we execute session dot run power operation, then it will execute all this because it's dependent on add op. Suppose you take this is the power operation, so it is dependent on the add operation, and add operation is dependent on this too. So this graph will be executed and for getting this add op, and then again for multiply op, again the multiply op graph will be executed and then it will compute it. However, this useless graph won't be executed because it is not executed in the session, so it is just defined. So this resources, so it will save the resources by this way, because we'll not be computing the useless operation. Only for whichever computation you run in the session, and if this computation is dependent on whichever defined operations or variables, only those will be executed. So in this way we save the computation, we run only the things that is required. Okay, so that is advantage of graph. And also we can break the graph into several chunks and run them parallelly across multiple CPUs or GPUs. So for example, AlexNet, they're executing this part of the graph in GPU 1, this part of the subgraph in GPU 2. So that's why all the TensorFlow structure is defined in form of graph. So it's quite efficient. Okay, so again, Y graph. So obviously it saves computation by only running the subgraph that lead to the values you want to fetch, as we see in one slide before. It will break the computation into small differential pieces to facilitate auto differentiation. It facilitates distributed computation across multiple CPU GPUs, and many common machine learning models already are commonly taught and visualized as directed graphs already. Okay. So one of the most exciting feature or tool of TensorFlow is the TensorBoard, and it helps you to visualize go deep inside what is going on in the network. So with this you can visualize your histograms or histogram of weights or biases. Then you can also visualize how your network is doing by monitoring the graph of uh, the loss should reduce. So you can visualize this type of graphs, or the accuracy is improving, this kind of graphs. And also you can visualize embeddings in higher dimensional spaces for your features. So I have done a video on how to visualize embeddings for your own data, and the link will be somewhere appearing on the screen, and I'll provide the link below also. Okay, so what TensorBoard is, it's a graph visualization tool included with any standard TensorFlow installation. And in a lecture at TensorFlow Dev Summit by Dendeli and Mane, he says that if neural network sometimes can be a black box, then TensorBoard is a flashlight. Okay, and he's right. So let's see what actually happens. So whenever a user performs certain operations in a TensorBoard activated TensorFlow program, these operations are exported to an event file. Then TensorBoard is able to convert this event file to graph that can give insight into a model's behavior. So let's see, suppose this is our TensorFlow program, and this is a graph which I drew it. So just to conceptualize this, I say elucidate this. So what will happen, there will be a writer file which will write this program or operations into a event file, and then TensorBoard will take this event file and kind of paint it in a graphical form, or in a form in which we can visualize. So this is the operation of adding. So you have two constants. So actually there are two graphs here. Just see, suppose there are two constant 2 is constant 3, and this is the add operation. So this is how it will appear on the TensorBoard, and we'll write this out. We'll do this we have a code in Jupyter Notebook. We'll try out in few slides. So what actually is the program for it? First is you define the operations, and then you define a location where you want to write all your logs or all the event, and then we start a session, and then we what to say we create a summary writer object which is going to write the session graph in this log directory, and then we execute those graph or those computation, and then we close the writer. Okay, so create the summary writer after the graph definition and before running your session. Okay, and once you have run your program, the event file will be in your log directory. And then how you can use TensorBoard to visualize it? So first is, excuse me, so first is you open that, what to say, your prompt or terminal where your, what is it, working directory is. You run your Python program, and then once you have run, the event file will be created. Then from there you execute TensorBoard, then the log directory and the port, and then in your browser you open this and you'll see it. So let's do this in a Jupyter notebook. Okay, let's see how it is, where it is. So
Okay, so let's see how we can visualize the graph in the TensorBoard. So here's the example, and we have the same operation. We'll have two constant and one add operation. So these all are, part of defining your graph. So let me run this, and yeah, so you have to give the location where your event file will be stored. So you see, this is my working directory, and there is no any such directory name event logs. But when I run this, so it will create an event log file, and inside that my event will be stored. So we'll start a session. We'll create a writer object, and we'll give session.graph, because we are trying to visualize the graph, and we'll give the directory or location where the event need to be stored, and then we'll run this session, and then we'll close the writer object. So let me run this, and yeah, 100 plus 112 is 112, and let me close this. And okay, so now you can see here there is a event logs new file, sorry, directory, and there is an event which is stored here, or on 30th November 9:40 p.m., which is just now. Okay, so now let's see how we can visualize and launch the TensorBoard. So let me go to the location. This is my Anaconda prompt, and I am at my tutorials, TensorFlow and Python notebooks, and here this is my directory where uh, my event logs are inside TensorFlow Python notebook. And so I'll execute here by, let me see what the command is. It's TensorBoard and minus minus log directory, which is equal to event logs new, and I'll give a port of 6006. So let's run this, and then we have to open a browser and go to localhost 6006. So let me just open it here, and local host, it's 6006. Let's see if oh, what's that, ping? Okay, let me open Chrome here. Okay, it's here, localhost 65. Great. So now you see this, you can see your graph. And so actually, if you notice here, let me minimize this. So you see, where is it now? Yeah. So if you see, we had just one operation, one graph, but here you see two graph. And why exactly it's this? Because previously we have executed this operation or this graph. So this is that graph, and this is the second graph. So since we haven't restarted this notebook, both the graphs are actually in the default graph of TensorFlow. So you can either define new graph, but here we haven't defined. So we are using a default graph, and in the default graph, the previously executed graph as well as this graph is there. So you can be very sure of this. If you see, uh, so this is this constant, its value is 2, and this constant, its value is 10, whereas what we executed just now was 12 and 100. So this is it, you know. So this is the where is it again? Yeah. So this was the 2 and 10 referring to the first graph, and this is, you know, uh, 12 and 100 referring to the second graph. Okay. So what, and if you want to delete your previous graphs and also consider this, let me show you how you can do that. So I will just, yeah, I'll just close this and I will delete this event file. And in this, I am just showing you how to visualize the graph in the TensorBoard. So there are a lot of other options which we'll see later, like scalars, distributions, histograms, images. So this we'll see later how we can utilize them in our code. So yeah, I'm showing you how you can get rid of this first one. So you have to restart this kernel. Okay, so the previous loaded graph will go, and I have deleted this log file. So now I'll just execute, this one graph of this TensorBoard, okay, directly. So now if I execute just this one graph and this one and close it, and let's go and run the TensorBoard, we'll again give the directory where our logs file are and the port, and let's go and launch the TensorBoard here by localhost. So now if you see, there is just one graph, okay, and that's referring to the one graph we loaded here. So again, if I execute it, the same code, and yeah, but I haven't closed, I think this one. Okay, it says it's overwriting. Okay, let's see what happens if I refresh it. So now you see I get two graphs. This is the same thing. This is a 12, here's the value, and this is 100, and this is 12, this is 100 again, and this is the add operation. So this was just to show you how we can launch the TensorBoard and use it to visualize the graphs. And as I told earlier, we'll look into all this. And yeah, so let's get back to the presentation, and let's.
So these are some of the, so as you saw here, I don't know, in the, okay, let's forget it. So in the TensorBoard, you would have seen that on the side there are all the symbols. So these are actually what the symbols mean. So this is the name scope, which we'll discuss, and this is, summary. This is an individual operation, and okay, we will see as we go. So this is a TensorBoard which will for Python 3.5.2 and for TensorFlow 1.0.1, and this is a TensorBoard for Python 3.6, TensorFlow 1.3.0. So why I'm showing this, I have both this and both the TensorFlow, and I mainly use 3.5 and this one, but this is the latest one, and you can see the difference between, not big difference, like in case of TensorFlow 1.2.1. So you see all these different attributes are shown horizontally, where here they are given in a list. Okay, and there are as we move in the next slide, I'll show you why I use 3.5 and TensorFlow 1.2.1. But let's move ahead. So when we're visualizing graphs, so what I showed you earlier, it's a simple, add operation. But when you're defining neural network, you will be making some complex graph like this. Okay, and in order to understand it, we should name it. So like I told that this symbol, as we saw earlier, this square symbol is called name scope. So it's a kind of defining one functional block, and called like SGD trainer, and inside this there are different operations and everyone has their name. Okay, similarly this name scope is called logic layer, and the name of operation is bias add matrix multiply, and this name scope is ReLU layer and its name is BW matrix multiply bias add. So let's see the naming of operation and the name scope. Okay, so let's first see the naming name ops or naming of operation. So if you just see, this is A B C, and if we haven't given any name to any of this uh, operations or the input nodes, and when we write this graph in a file writer and we visualize in TensorBoard, you will see that it gives some random name, like this one was constant 1, constant 2, constant 3, and if there are two add operation, it will be add and add 1. So this is given by TensorFlow default. What if we want to name it? It's like in order to recognize it. Okay, so you can use it using the keyword called name. So when you're defining this op c tf dot add a comma b, you can even give it name like addition. So when you visualize this, now instead of add default which TensorFlow takes, now it will take what name you have given here, such as addition. Okay, so this way you can name the operation. And how you can give name scope. So name scope is like giving a name to a block of operation. Okay, so we can do this using a with block. So let's this is a graph. Okay, so let's see with tf dot name scope input. So with this name scope of input, we are defining this three ops. Okay, so a we are giving as input a, b we are naming it as input b. So now you see, instead of naming it as a constant like it in the previous slide, just name it as input a and input b. Okay, and yeah, and yeah, simply here we haven't given any name, so it will simply take add. And similarly, uh, uh, this is the add is within the scope of add output, so it's add output. The subtraction is within the scope of subtract output, and the multiplication, we have two multiplication operation, multiply 1, multiply 2. So this is within the name scope mul underscore output, and this is mul2 and mul1. So mul1 is taking input from add output and subtract output, and mul2 is taking input from input f and output of multiplication 1. And we'll create a writer file, and then we'll run in a session all these operations, and we'll get this graph. So let's run this in our Jupyter notebook and generate this. Okay, uh, let's keep it. So here it is, and I have restarted. Let me restart this kernel so I get clear of all those. Okay, so here we execute this. Here we'll just see the naming of ops in this block, and we'll run this in session. We didn't define the log directory because we restarted. So let's run this log directory, and then let's run this. So it's done. So now if you execute your TensorBoard and launch your TensorBoard, I mean, so sorry, this was the previous one. Yeah, so now if you see, it's just this one operation called name addition. So it says name as addition, inputs are a and b. So now let's run this also, this block with name scope. And so I'll give a link to where I'll place this notebook, my GitHub link, and you can access this notebook and try out yourself. But let's first see what's coming here. Let's refresh it. Okay, so now you see this was the previous simple name operation, and this is with the operation we did with name scope. So multiply output, its input is input f, and if you click here, so it says the input is coming from multiply 1 and input f. Okay, you can zoom it, you can zoom out, and you can see whatever you have written in your code will be visible here as a graph input and where the output is going. Okay, but and these are the different symbols that I was telling what's the name of those symbols. So you can look in TensorFlow official website, and they have tutorial on that. And yeah, and you can you can download this graph as PNG image, and you can trace the inputs. So what this is, so suppose if you click this, so it will be showing only which inputs are to this add operation. If you click this, it will show you this are the inputs. Or okay, but one thing which I didn't like here with Python 3.6, and this is like, suppose if you see here this connectivity and all, that is not there. I don't know why, or am I missing something, but I don't think so. So that's why I use Python 3.5, and you will see in 3.5 how this graph appears more connected. It will be, like this form in Python 3.5, and the latest version of TensorFlow 1.4.0. So it, as to discuss earlier, we can just do a pip install in Python 3.5 environment, and you will get the TensorFlow 1.4.0 and in Python 3.5. So let me get close this in Python 3.6, and let's do in Python 3.5. So this is my Python 3.5 TensorFlow 1.0 environment, and let me run the same thing. So you see here, so this, there is no connectivity and graph and all, but let me run it in Python 3.5, and you will see something interesting, provided it ran. What happened here? Okay, okay, so I think, yeah, it's running. So let me just refresh it. So you see how clear the graph is. So it clearly shows that this multiply 1 is taking input from add output and subtract output, and this multiply 2 is taking input from input f and multiply input s, we have written in our graph in the notebook. So you see, you can like visualize the graph in a better way using this Python 3.5. So I would say use that, and that's upon you to how you want to visualize using Python 3.6 or 3.5. So
So TensorFlow will take like Python native types such as Python Boolean values, constant values, strings and all, and they will convert in tensor. So since TensorFlow take input as tensor and output as tensor, it will convert everything in tensor. So scalar values will be converted to 0D tensors, and uh, the list values will be converted to 1D tensor or the vectors, and list of lists like they will be converted to some 2D tensor like matrices. So if you see this is scalar value, it is a zero-dimensional tensor. If it is a list, like this, then it's a one-dimensional tensor, a vector. And if you have list of lists like this, then it's treated as two-dimensional tensor or matrix. Okay. So like NumPy, TensorFlow also has its own data type. So I'm just giving an overview of all this. So you can go to the Stanford course if you want to go get in depth knowledge of TensorFlow. I just want to give an overview and getting started with implementation and all. So like you know Python, we have in TensorFlow we have tf.float 32, float 64, tf.integer, tf.complex, tf.uint 8, like as we have in NumPy, np.uint 8 and all. So it's there is a point here that most of the times you can use TensorFlow types and NumPy array types interchangeably. Both TensorFlow and NumPy arrays are ND libraries. NumPy supports ND array, but they will not create tensors and all. Python type lacks the ability of explicitly stating the data type, but TensorFlow data type are more specific. So all the integers are of same type. In NumPy, all the integers are of same type, but in TensorFlow they are 8-bit, 16-bit, 32-bit, 64-bit, and all. So you can use interchangeably, but it's advisable just to use TensorFlow when you're using TensorFlow.
so coming to the last part of the concepts of TensorFlow. three of the very important things that you need to know is constant, variables, and placeholders, especially variables and placeholders, because we are going to use them during our executing the network in TensorFlow. So let's see what they are. So constant is a constant. It can be a number, like number 3 is a constant, or it can be some string like apple. So it some like its value doesn't change. But there's a disadvantage of constant in using in TensorFlow graph, because constant are stored in the graph definition. So first, when we define the graph, we are just defining the graph, and when we run the session, we kind of execute those computations, we take the values and all. But in case of constant, they will be loaded every time we load the graph, and it will become slow, especially when constants are big and all. So it's better we don't use them. We mainly use variables if we have to use store large values and all. So let's see in the Jupyter notebook if we run this part of the code. And yeah, this part is also taken from Stanford notes, and again you can go there and have a look, or a very detailed explanation about everything. So let's first import the TensorFlow, and the constant can be like a 1D tensor like vector like this one, or it can be a matrix like 2D tensor like this one. So you can define any form about it. And you can also like np dot zeros, np dot ones, you can also define constant with TensorFlow with same tf dot zeros, tf dot ones, and it will tell you the shape and data type. And yeah, so we just print, and you can see it's a 2D matrix of constant. And then you can also create constant that are of sequences like line, so tf dot line space, and you will see here sequence between created like 10, 11, 12, 13, 4 sequences from 10 to 13. And then you can also define ranges like we do in NumPy. NumPy, the np dot range or np dot x range, and it will give you range. So from 2 to 20 with a gap of 5, so it's 2, 7, 12, 17. Or tf dot range of 10, when we run that through session we get 0 to 9. Okay, so it's very much similar like NumPy. And yeah, and sorry, yeah. And when we like suppose consider this one, and this is a constant, and we just run the default graph, and you can see it is loading the value of the constant, and it can be memory expensive. So we go for variables, and you would be knowing about variables. So but in TensorFlow, how we can create a variable, we have to create an instance of class tf.variable. So A is a variable, we'll create an instance of the class, and here we are giving the value of variable as 2. We can also give the value of variable as a scalar, a vector, or even a matrix, or a tensor like this one. So we'll be seeing this especially when we are initializing weights and all in neural network. We'll be using the variable. So considering MNIST example, so the variable can be initialized as 784 comma 10 shape, and its value will be initialized with zeros. And in this case, so you can initialize with any other values later. So as said, like these are the values that they are going to have. They're not being initialized yet. In order to initialize these variables, we have to run the initializer, and we have to run it through a session. So to initialize, we use tf.global variable initializer. So it will initialize all the variables. So we create a variable init as tf.global variable initializer, and when we run the init, those variables get initialized, and we can see their values also. So yeah, this is one, like you can initialize the all the variables by this global variable initializer. So it will initialize a b c w everything. And another way to initialize the variables is to initialize part of it. So suppose you say I give init ab a variable where I'm initializing only a and b. In the previous case I was initializing a b c w. In this case I'll be initializing a b, and then I run that init ab through this session, and only those two variables will be initialized. Okay, and also we can initialize a single variable by just giving this. So w dot equal to tf dot variable tf dot zeros, this we define the variable, and then simply we write this variable dot initializer instead of global initializer or giving a subset of variables. We can just initialize a single variables too. So this was for initializing variables. Now how you retrieve the value of variables. So you can retrieve the value of variables using eval function. So let's see. So suppose this is a variable tf.variable tf.truncated, and we initialize it and we are printing this variable. So let's print and see. So you see that we don't see the values here. We just see it's a variable 4, because previously we have initialized. So it gives a variable number, but there is no value, and it gives its shapes and it gives data type, but we don't see its value. So for that we have to use a eval function. So this is the eval function. So we have to initialize the variable, and then in order to retrieve the value we'll be using w.eval. So let's run this, and you see here that five 5 rows 2 column matrix variable is shown here, which is a normal distributed. So this this you have to remember in order to retrieve the value of a variable. And then we can also assign values to variables using this tf.variable.assign. So let's see this example. So consider w as a variable 10, and we are assigning w as 100. So, and inside the session we are running w.initializer, so it will take the value of 10, and when we print it, it should print 10. So let's see. Yeah, it's printing 10 on evaluating. And we have, and it's not assigning 100 because we haven't run this. So let's see here. So we have to run this assign as an operation. So this is a variable and this is the assign op, and inside this if we run you know this if we run this assign op, and now it should print 100 because we are running this assign op, so it's 100. So using variable dot assign, you can assign any values to the variable. And uh, yeah, so anything more? Yeah, and you can also do like the increment and decrement function. So in case of Python or all, we use variable plus plus or variable minus minus. Here you can use, in order to increment to some specific value, we can run this w dot assign add. So assign add is the command for incrementing, and incrementing by the value 10. So here suppose take a variable whose value is 10. It is initialized, so its values get assigned, w's values get assigned to 10, and then we run assign add, so increment it by 10, so it should print 20, and then we subtract 2, so after 20 it should print 18. So let's see. Yeah, 2018. So this two are the commands to increment or decrement. Okay, so this was about constant and variables. So let's go to one more important concept of anything more. Okay, so one important thing is placeholders that we'll be using in training our network. So let's see what a placeholder is. So first let's go by literature meaning. So what do you think if you say place holding a place for your friend, suppose in bus or in restaurant? So you keep something and you hold that place, although the main value or the main person is not there, but still that place is hold or reserved for the person who is going to come. So we just assign, or would say hold that place. So that's what it means even in TensorFlow. So as you know, in TensorFlow program, we'll have two phases, as I've discussed a number of times in the beginning. We first define the graph, or assemble it, and then we execute the operations in the graph. Okay, so you can see that we can assemble the graph first without knowing the values needed for the computation. So that's what placeholder is. Like as I told, we can define the, without knowing what the actual values, or without knowing, without like the person being coming to the seat, we hold that place. So consider this analogy given by this lecture. So they're consider a function fxy equal to x cross 2 plus y. So this is the function being computed, but we don't know the value of x and y. Okay, so this x and y are the placeholders where we are going to feed the actual values. Okay, so it can be defined using this type tf.placeholders. We have to define the data type, and you have to define the shape, and you can give the name also. We can give the values later. So this will be used during the training. So we can assign the shape of inputs and the types, and then we can feed those values later during the training rather than in the defining in the graph. So you can create like this. So for example, TF placeholder, its type is float 32, its shape is 3. Then another uh, what to say, it's create a constant type float 32 with shape is a vector of 3 element. So this is uh, this is just a constant, and use the placeholder as used as a constant or variable. So you define a placeholder and you define a constant here, and then you do this c equal to a plus b. But when you run this, it will give an error because the a doesn't have any value, it's just a placeholder. So in order to run this, you have to feed the values, and we feed the values through a dictionary. Or if you have executed TensorFlow program, you'd be knowing this feed dict variable. They use it, feed underscore dict. So suppose this is a placeholder, okay, shape 3, and this is a constant, and this is the addition operation. So what we do now is, in order to get the value of C, we'll run it through a session, but we'll feed the value of A through a dictionary. So A equal to 1, 2, 3. So when executing this, now it will give you a correct answer for this. So and this example you see in, for example, when you're doing MNST training. So you start a session, you initialize all the operations, and you get your input batch x batch y from here. And when you're running this train operation, there you have defined some placeholders for the input, placeholders for the x, sorry, where is it, placeholders for x and placeholders for y. And that placeholders we are feeding it during training through a dictionary. Okay, so this is how we use placeholders. Okay, so yeah, let's first uh, see in Jupyter Notebook and see the values so you get a better understanding. So let's look into the example of placeholder. So as we saw that we can define the values and define the variables, and we can feed the values later. So those are the placeholders, and we can define a placeholder using this operation tf.placeholder, describe the data type, shape, and name. So if the shape is none, which means the tensor of any shape will be accepted, and accepted feed values means whatever values that a placeholder can take, it include Python scalar, string list, NumPy, and n-dimensional arrays or tensor handles. So let's see an example. So here I define a placeholder of float type, and I have given its shape as none. And then I define operation y, which is this placeholder into 2. And then I run this session y simply. So let's see what it gives. Okay, so you see there's an error because we haven't fed any values to the y. So it's just a placeholder without any value. So let me do what in the next segment. Let me feed these values to the x value. Okay, so x is just a placeholder, and we are feeding the values 1, 2, 3 through a dictionary here. So when I run this, I should get a value of 246 because y was x into t. Okay, so this was just one example. So let's see another example where I define a placeholder of a two-dimensional placeholder of shape none comma 3. So it can have any number of rows and 3 columns, and y is again x into 2. So in this I am feeding a 2 cross 3 matrix data, and I'm feeding it through a feed dict a dictionary. And when I run this, you get it 2, 4, 6, 8, 10, 12. Okay, and we can at a time, through feed dict we can give more than one input variable. So here we just give one, but for example, say you're training your network, there you have to give two values. One will be your input data and another will be output data in case of supervised learning. So here I have two placeholders C and D, and an operation which adds them, and I give values to these two placeholders through this fit dict, and through two placeholders are separated by a comma. So we have session.run z fit dict C is to 2.1 and D is 1.5. Let's run this and you'll see the value 3.6. That's cool. And we can also visualize this in TensorBoard. So let me write this in a summary file writer, and in a my graph directory session.graph. And so here the event will be in my graph somewhere here, and there is some old event also. So let's see by running it in TensorBoard. And so yes, let's run his, and let's see. Oh, I got a lot of tabs open. Let me give a local host TensorBoard. So you see, these are the functions we define, and actually again this is the Python 3.6, and so there is no connectivity between the graphs. And also let me do this in Python 3.5, as I showed earlier, to in order to see the connectivities nicely. And if I run this and let's refresh it, and you can see, so this is the connectivity. So this is the placeholder which we defined, and it was y equal to x into 2. So you can see the operation also. So there's a placeholder, there's a multiply, and again the second was shape of n comma 3. So there is question mark into 3, if you can see it here. And the another was two placeholders, c and d, and those placeholders were feeding the input to the add operation. Okay, so this is about the placeholders, and I guess that is pretty much from placeholders. So in this video we just saw a broad overview of TensorFlow, and will as we implement the network, the all the concepts will become more clearer and it will come more handy. And yeah, so tune into the next episode 1.3, where we'll discuss a detailed overview of keras, and we'll see how easy the keras is, and we will just look into it because we are going to implement our networks in both TensorFlow and keras. And if you like the video, then just like it, and if you have any questions you can comment below, and if you want notification for it you can subscribe, and if you want to support me you can support me on Twitter and PayPal. And till then, keep learning and keep exploring neurons. Thank you. Bye.